Function pointers are one way to gain a very powerful capability, and that is deciding at runtime what code to execute. And to a certain extent, you have that just with an if, right? If something or another, block of code, else some other block of code. But you get into situations where you want to sort of separate making the decision about what's going to run from actually running it. And in C, the only way to do that was through function pointers. You'd have some kind of an if that would set the value of a function pointer in a variable, which would wander around with you for a while until you went to use it, and then you would invoke whatever function you had set the function pointer to point to. Now, if you hear that problem description, it's normal as someone who's learned some C++ now to say, well, couldn't I just use polymorphism for that? You know, create the right kind of subclass if I have saving account, checking account, retirement account, whatever. Then I carry it around as a base class pointer, as an account pointer, and then call its update method, and the right code will run. Absolutely. That is a fantastic solution to that problem of different code running depending on the circumstances you're in. As well, you may be ringing a bell on lambdas and saying, aren't lambdas kind of a way for you to just to plunk the code you want to execute right there? If some condition, do this passing in this code for the second parameter, otherwise do this passing in this code for the second parameter? Sure is. Also another way to do it. In most cases, either polymorphism or lambdas are likely to be a better way to go. I still run into circumstances where I use function pointers, but less often. However, what I'm really all about in this module is helping you to read some really opaque, punctuation-rich code that you don't understand what it's doing, and function pointers definitely can fall into that camp. Now, setting and using them, especially if it's a global function, super easy. Take a look at this. I set some variable method, which I cleverly haven't shown my declaration of method, to a value. And calculate slowly is the name of a function. Now, if I had round brackets, calculate slowly, open round bracket, close round bracket, semicolon, I would be calling the function and putting the result into method. But that's not what this line of code is doing. It's actually setting the function pointer to point to the calculate slowly method or function. The next line, which says method at A, B, and C, will actually execute calculate slowly at A, B, and C. Now, of course, just like when we first did pointers, you know, if you say int I, int star pi is equal to address of I, and then star pi equals something, woohoo, that's just like saying I equals something. And you're like, so what? So it is here. These lines aren't very useful when they're right after each other. I could have just called calculate slowly and passed in A, B, and C. Where they become useful is when method doesn't get called right immediately after getting set, gets sort of carried around and used later. Now, to declare that function pointer, everybody uses a typedef. It's a reasonably tricky thing. You don't want to be doing it repeatedly. So the typedef says that changer is a pointer to a function that takes an integer called I and returns an integer. You sort of have to read them inside out. Now, once you've done that, then they're easy to declare instances. So I just say changer f. I have a file here called functions.h, which is included into my main. And I have a pair of global functions. These aren't member functions of any class. They both have the exact same signature, and that's vital when you're working with function pointers. The function pointers are typed. So a pointer to a function that takes an integer cannot be used to point to a function that takes 3 strings, and vice versa. Just as a pointer to an integer can't be used as a pointer to an employee or something. Both these functions take an integer and return an integer, and they're reasonably well named. Doubler takes an integer and returns double of that integer. Tripler takes an integer and returns triple of that integer. So far, so good. There's nothing function pointery here. I'm just creating things for the function pointers to point to. Then I have my typedef. So this typedef says that changer is the type I'm defining, and it is a function pointer. The combination of the star, which would mean pointer for anything, and the open bracket here is a function pointer to a function that returns int and takes a single integer. This may not be entirely logical. You may not particularly like it, but you can memorize it or look it up when you need it. This is the way to typedef a function pointer declaration. Then once you've done the typedef, life is pretty simple. Let's look at this change function. I declare a changer f. So f is a function pointer that can point to any function that takes an int and returns an int. And here I'm going to set f to either point to tripler or to doubler. And then I'm going to use f. So I triple larger numbers, numbers that are more than 5, and I double smaller numbers, numbers that are not more than 5. Let's go back to my main. I have I1 here who has a value of 7, and L1 who has a value of 3. 7 clearly is more than 5, 3 is not more than 5. So I'm going to call change and I'm going to pass in I1, which is 7. And I'm also going to call change and I'm going to pass in L1. And just to be on the safe side, I'm going to cast that long down to an int so that everybody really knows what's going on. So let's set a breakpoint here and run to this point. I can step into this function. And as I step through it, you can see that I, that's the parameter I was passed in, is 7. And f is really not anything yet. In a debug build, that's an uninitialized memory. We go into the if because 7's more than 5, and we're going to set the value of f. And the debugger actually understands that it's a function pointer and can show us that it's now pointing to tripler. So I step over again, and if I step into this call, you can see that I actually find myself inside tripler. Now, not surprisingly, 7 times 3 is 21. We can work our way back out. And you can see, if I just step over one more time, that I2 has the value of 21. We tripled the larger number. Here I'll just step over it to be a little bit quicker, and you can see that I3 has the value of 6. We only doubled the smaller number of 3. So that is how simple it is to use a function pointer once you have it set up. The typedefs are definitely your friend. This is a tricky piece of syntax, and what's worse, if you get it wrong, the error messages are a little bit opaque. So all of these round brackets are necessary. This pair of round brackets representing the parameters that are passed to the function, and this pair of round brackets highlighting that you are actually declaring a function pointer.